Okay, Assalamualaikum and very good day everyone. So this is lecture 3 on reaction kinetics. Okay. Okay, so this is the second method, the initial concentration method or initial rates method. Okay, so this is a next subsequent problem. We have here the data for the reaction between A and B are as shown in table below. Okay, so in this kind of problem, you are being given sets of data which consists of concentrations of the reactants with its respective initial rates. Okay, so in here we have several experiments. Okay, firstly we have 4 columns. Okay, and these are the experimental data. The experimental data from the experiments which has been done. Okay, initial concentration of A, there's several there. From experiment 1 to 4, we have 3.0 times 10 minus 5, 6 times 10 minus, 3 times 10 minus 2, 6 times 10 minus 2, 12 times 10 minus 2, and 9 times 10 minus 2. For B, we have a constant B at experiment 1 and 2, reduced B 2.0 at experiment 3, and higher B, probably an excess of B at experiment 4. And the initial rate, okay, there is a change. At experiment 1, we have 12 times 10 minus 5, which increased to 2.4 times 10 minus 5. Okay, if you can see there, let's do some analysis on this data. There's some clue actually on this data. If you look, okay, for experiment 1 and 2, the initial concentration of B is kept constant, 4.0 times 10 minus 12. Okay, and the concentration of A is increased twice, from 3.0 times 10 minus 12 to 6.0 times 10 minus 12. And when we do that, the initial, okay, when the concentration of A is increased at the expense of keeping the concentration of B constant, which means we only change the concentration of A, then we identify that there is an increase in the rates of the reaction. The rate increases from 12 times 10 minus 5 to 2.4 times 10 minus 4. So there is an effect on the concentration of A towards the initial rates of the reaction. So how are we going to solve for this problem? Okay, we are going to get the order of reaction with respect to A, the order of reaction with respect to B, the overall order of the reaction, and also the value of R4 there. Okay. Firstly, in order to determine the order of reaction with respect to A, we have to use some of the clue that we can find in the equation. Now, concentration of A to the power of m times concentration of B to the power of n over concentration of A to the power of m times concentration of B to the power of n equals to R2 over R1. What does this mean? This means that we are going to take the concentration for both A and B, okay, at two different experiments, okay, with two different values of initial rates. Now, and then we try to substitute the values of the concentration into this equation, and also we have to substitute the initial rates values into its respective position. Now, concentration of A to the power of m is 6 times 10 minus 2. For experiment 2, R2 means the initial rate for experiment 2, R1 means the initial rate for experiment 1. Now, concentration of A to the power of m is 6 times 10 minus 2 to the power of m times 4 times 10 to the power minus 2 to the power of n over 3 times 10 minus 2 to the power of m times concentration of B, which is 4 times 10 minus 2 to the power of negative 2 n. I do have to apologize because just now I mentioned to you the power for the concentration is 2. It is supposed to be -2 for all the equation, for all the concentration, because we have to refer to the table. Okay, so we stop at 4 times 10 minus 2 for n, which is equals to the initial rate for experiment 2 is 2.4 times 10 minus 4 over 12 times 10 minus 5. Okay, so now we can actually cancel out the term for b. Okay, and we cancel that 2 out, then we have 6 times 10 minus 2 to the power of m over 3 times 10 minus 2 to the power of m. Okay, and equals to 2 to the power of 1. Okay, because we saw for the initial rate. Now 6 is actually 2 times 3, so we take out the 2 outside from the bracket. We have 3 times 10 minus 2 to the power 3 times 10 to the power minus 2 m, okay, times 2 to the power of m equals to 2 to the power of 1. So m equals to 1. Now from here we know that the order of reaction with respect to A is 1. Okay. Determine the order of reaction with respect to B. The same equation we put here. Okay. Concentration of A to the power of m times concentration of B to the power of n over concentration of A to the power of m times concentration of B to the power of n equals to 3 R3 over R1. Okay, how do I know this? Is it R2 over R1 or R3 over R1? Okay, the clue is you have to look at the experimental data. Okay, the experimental data will give some clue. If you keep this constant, you vary this and the rate will change. Is it increase or decrease? Okay, so from there you can do some calculation. Okay, from here, let's expand this and insert the value for A and B for each experiment. Okay, in this case, experiment 3 over experiment 1. Okay, just now from our previous calculation, we know that the power for concentration of A is 1. And we insert the value of m, which is equals to 1 in this equation. Okay, so we have 12 times 10 to the power of minus 2 times 2 times 10 to the power of minus 2 to the power of n. We are going to get n here. Okay, over 3 times 10 to the power of minus 2 times 4 times 10 to the power of minus 2 n. Okay, equals to 2 to the power of 1, because the initial rates for experiment 3 over experiment 1. Okay, now we can slash or we can cancel out certain things here. As you can see there, we can cancel out 3 times 10 minus 2, 3 times 10 to the power of minus 2. Okay, we can cancel that out. So we are left with 2 to the power of n. Okay, and we also cancel out 2 times 10 minus 2 over 2 times 10 to the power of minus 2. We cancel that out, so we are left with 2 to the power of n, which is equal to 2 to the power of 1. Now, because of that, n equals to 1. So the order of reaction with respect to B is 1. Now, determine the overall order of reaction. The overall order of reaction is 2 because R equals to K times concentration of A times concentration of B. Concentration of A is 1, concentration of B is 1, so we have R equals to, we have the overall order, which is 1 plus 1 is 2. Determine the value of R4. R4 is the initial rate for experiment 4. In order to solve for this, we have to solve for K first. Because, why? If you look at the rate law, we have R equals to K times concentration of A times concentration of B. Okay, so in order to get the initial rate, the rate, okay, R, you need to have three parameters. The K, the rate constant, the concentration of A, and concentration of B. From the problem, concentration of A and B are given, so you need to find the value of K. Okay, the value of K is R over concentration of A times concentration of B. Taking any of the experimental data, in this case, I have taken the data from experiment 1. So K equals to R over concentration of A times concentration of B. For experiment 1, we have K equals to 12 times 10 minus 5. Now, the unit here is mole per dm cube second. Okay, over 3 times 10 to the power of minus 2 mole per dm cube times 4 times 10 to the power of minus 2 mole per dm cube. Mole per dm cube, okay, from the numerator can be cancelled out with one of the denominator. Okay, and after calculation we get K as 0.1 dm cube per mole per second. The unit must be correct. Okay, we insert the value of K into the equation. R equals to K times concentration of A times concentration of B. Okay, so we have the value of R, which is 1.08 times 10 minus 3 mole per dm cube per second. Okay, thank you very much. I hope this will be beneficial for you. You might have to listen to it more than one time, okay, several times, in order for you to understand on how to solve for problems. Okay, okay, thank you very much, and assalamu alaikum.